All right, this is going to be hopefully a short segment in which we're going to talk about unit conversion. Right. Now, before you just stop the video or walk away and say, I learned how to convert units several grades ago, just bear with me a bit, okay? Unit conversion is a skill that people often make mistakes with, right? It's not that I feel like there's some of you that just never learned to do this. It's that I know from experience that a lot of you will make mistakes, and those mistakes will cause you to miss problems. So since we don't want to be missing problems, it's worth a few minutes to make sure we're on board with how we're going to do this, okay? All right, I also know that in this particular course, a lot of different kinds of problems, things that seem like they're chemistry problems and not just unit problems, can be turned into unit conversion problems if you think about them right. I'm going to try and encourage you to be able to do that. All right, so let's go and look at a couple of slides here, okay? First up, anything that is a measurable quantity, physical entity, should come with units attached. The only exception to that is something that is a pure number, like a number of things. Okay, in chemistry, that means if we talk about a number of molecules, typically we might not think about molecules as a unit, right? I would just say I have 10 to the 20th of them or what have you, right? But other things, if we talk about masses, we talk about volumes, we talk about concentrations of solutions, anything like that, it wants to come with a unit. And manipulating those units as you go through calculations is a frequent source of struggle, okay? Basically, any arithmetic operation that you're doing on a quantity, you have to do it on the unit as well. Okay, so we'll look at an example in a bit where this particularly gets people into trouble is when quantities are being squared or cubed. There are a lot of problems that show up in this particular chemistry course and lots of chemistry areas that can be thought of as unit conversion. Why is that? It's because in chemistry we talk about stuff, about matter is the textbook word for that, right? And so oftentimes we want to know how much stuff are we talking about, right? If I have a sample, I might describe it by saying I know its mass, I have 15 grams of it, or I might say I know its volume, I have some number of milliliters or liters, okay? I might rather know how many molecules are in there, or in chemistry, we often count molecules in terms of something called a mole, which I'm pretty confident all of you will have seen in high school chemistry. I'm less confident that you actually feel like you know what it is, but we'll get to that in a couple of classes or so. Okay, so there's a lot of problems in chemistry. In another week or so, we'll be doing problems that involve converting masses to moles, to numbers of molecules. And that's really just a problem where we're changing what kind of units the amount of stuff is in, right? I'm saying this is what I've got, but do I want to describe it in terms of how much it weighs, what its volume is, how many molecules it is, things like that. Okay, and so that's what we're going to be doing in many cases. All right. I have here an example about unit factors, and it looks like I already scribbled on the slide and forgot to erase that, but that's okay. Any pair of units for the same quantity, if I have two length units, centimeters and inches is the example I've got here. I could have two mass units. I could have a simple one, I could have grams and kilograms, or I could have grams and pounds, or grams and tons, or whatever, right? I can define some equality that relates them. Right. For the case of it being centimeters and inches, 2.54 centimeters is equal to 1 inch. That 2.54 happens to be an exact number. That means if we were really being diligent about keeping track of significant digits, the 2.54 has as infinitely many, as does the 1 inch in this case, because those are both exact quantities. Okay. You'll be relieved to know that in most cases I am not all bent out of shape about significant digits. Try not to be ridiculous about them. I'll talk more about this when we get closer to you taking quizzes and exams, where because things are going to be being assessed by computer, it is important that you get within a reasonable tolerance, and we'll talk about that when the time comes, okay? These factors can be used in either direction. Okay, so that means I can say if I know 2.54 centimeters equals 1 inch, I can convert from inches to centimeters or from centimeters to inches, okay? When we do this in textbooks, we write these things like fractions, and we call those things unit factors. Okay, in this case, there are two different unit factors I could write. I could write this one over here, which says that has 2.54 centimeters on the top and 1 inch on the bottom. So that would be handy for converting from inches to centimeters. Over here, I've got just the inverse of that, which would be useful for converting from centimeters to inches. Either one of those fractions can be said to be equal to 1 because the thing on top and the thing on the bottom are equal to each other, right? That's the definition of a fraction that's equal to 1. And so I can multiply anything I want by those fractions and not change their actual value, right? I'm not changing what the quantity is. I'm just changing what unit it's described in. So let's do a really simple example. I'm going to convert 6 feet into centimeters, and I'm going to pretend the 6 feet is an exact measurement, I think, for purposes here, okay? I don't happen to know off the top of my head a conversion factor for feet to centimeters. I'm a nerdy guy, but not quite that far gone. I do know that a foot is 12 inches, and I know that an inch is 2.54 centimeters, so I know I can do this with those. Rule number 1 for doing calculations of this sort and for doing lots of chemistry problems is we want to start with the thing that we know. Okay, you'll hear me say that a number of times as we work chemistry problems. I'll say, what's the thing that we actually know for sure is what we're working with. In this case, the thing that I know is 6 feet. So I'm going to write down 6 feet. Okay, I want to multiply that 6 feet by things that are equal to 1. And so the first thing I want to do is say, right now I have feet. So I'm going to take my feet to inches conversion. And I'm going to say 1 foot is equal to 12 inches. I could stop there. If I did, I'd be on 72 inches, right? If I want to keep going, and I tend to do these things in one giant, just ongoing calculation, but you can always pull up along the way because all we're doing is multiplying. So it doesn't matter if we stop someplace. Then I'm going to say I want to put the inch on the bottom because I'm going from inches. I want to get rid of the inches and get the centimeters. Okay, so I get that one on top. And oops, I do that a lot, so I'm sorry. You'll have to get used to it. Over here I have 183 centimeters is what that's equal to. And just to be fair, I will confess that I'm cheating on that number. I did not just multiply those numbers in my head. I have a little note sitting next to me that says that's 183 centimeters, okay? If I really said the 6 feet was an exact number, then in principle, I'd be entitled to however many decimal places there I wanted. If I say the 6 feet has only 1 digit, then if I was playing by significant digit rules, I'd want to call this 200 centimeters because my result would also only have 1 digit. But again, that's not what we're going to obsess on. Notice that if you're lacking confidence when you do this, you can check and make sure you've done it correctly by saying the feet cancel and the inches cancel, right? And I didn't write centimeters up there, so that was a bad illustration of how to do this. So all my other units go away and I'm left with centimeters, okay? If I write one of those conversion factors upside down because I'm going too fast, if I keep track of the units, then I'll know that I got it wrong because then when I get done, my units won't cancel out properly, right? I'll end up with like inches squared over centimeters if I flip that last factor and put the 2.54 centimeters on the bottom. And I'll say, oh, inches squared per centimeter is not a unit I want for my 6 foot length, okay? One other point I want to make in this one, and that's this. The place where people have the most trouble with this is when units are squared or cubed. Okay, anytime that I have a unit, quantity raised to a power, if that quantity has a unit, then that unit also gets raised to the power. Okay, and this means we have to be extra careful about converting our units. Okay, so to illustrate this, again, going for simple examples here, ask yourself how many square inches are there in a square foot? It's a frequent occurrence in the first week or so of class because of a problem that we're actually going to do in the first live class session, I think, but one that comes up often in an early problem set is one that involves converting these squared or cubed units. And I'll say to a student, well, how many square inches are in a square foot? And maybe because you're just going back to school and getting started, a lot of times people will just blurt out 12, okay? And if you think about it, that's not right, okay? And so here's my square inch, or my square foot rather. So this is 1 foot, and this is 1 foot. That's my measurements. Okay. If I want to convert that to square inches, I have to remember that each foot is 12 inches, right? And so when I do this, now I have 12 inches here, and I have 12 inches down there. Okay, so now I know my 1 square foot is equal to 144 square inches. Okay, so I have to take that conversion factor. It's great if I know that a foot is 12 inches, which we all do, of course, at least those of us that have grown up in American units. Apologies to international students who aren't used to inches. we might have said that we could just take those 12 inches per foot and square it and get 144 square inches per square foot. Just make sure you take a moment and think about it, and that you're doing that process correctly as you go through, because that is a place where people often get themselves into trouble, okay? A few comments. This is me and a guy who is very fond of units for helping me solve problems, okay? We want you to try to develop good problem-solving habits. If you start doing that in the beginning of the course, where some of the problems are going to be relatively simple for a lot of you, it will help you out when things get going later on, okay? Number one, try to make a plan before you start doing math. Students are always in a hurry to finish a problem. And when you're confronting a problem, generally speaking, you want to make sure you know where you're going before you start trying to get there, all right? So think about, what's the strategy? What things do I know? What am I trying to find out? And what connects them up? Okay, then after you've got a plan, then it's time to start go to work on the calculator, say. Once you've done that and you do the arithmetic, one of the great things about this course is the math of general chemistry is really pretty much just algebra. Okay, and so the vast majority of you this semester, I'm told by the folks in math, are what they refer to as calculus ready, meaning you're supposed to be in Math 151 and higher courses. But in spite of that, you don't really have to do calculus to do this course, okay? There will be a couple times when I mention an idea or two from calculus, because again, almost all of you are at least learning that, but they won't be central to what we're doing. Once you have an answer, I encourage you strongly to just take a moment and pause and ask yourself, does that answer make sense? If you read the textbook in the example problems, we actually have a thing at the end which we try to say, okay, is this a reasonable answer? In a surprisingly large number of cases, you can get a little bit of a sense of that by just thinking about it. Okay, so when I was converting my 6 feet into centimeters, if I know that a foot is a lot bigger than a centimeter, then I should be thinking I should be getting a decently large number of centimeters, right? I got 183, that makes me feel good, right? If I got a fraction of a centimeter, then I would say that must have been wrong. I did something backwards or upside down, right? Ask yourself, do the units match what the thing is you're trying to calculate? If you're trying to calculate a mass and it comes out in liters, then you've definitely done something wrong, okay? And so make sure you've got units that are sensible for the quantity. Think about the magnitude of numbers. In chemistry, we work with some numbers that are very large and some numbers that are very small, right? If I count the molecules in a macroscopic amount of stuff, I might have 10 to the 25th power. If I talk about the mass of a single atom, say, I might have 10 to the minus 23 or 4th power, say, depending on what mass units I'm in, okay? So I want to know if that makes sense. If I talk about counting molecules, I should have a lot of them, right? Molecules are little. Any amount of stuff that we can measure is going to be a lot of molecules. If I get a fractional number of molecules, I know I did it wrong. Okay, and usually the wrong part is just that we did some step, again, upside down or backwards. And so try to guard against that by just looking at whether your answers make sense. The fact is you can stop yourself from making a lot of simple mistakes by just doing checks like that, okay? And if you do that, if you learn to do that when you're solving problems in your homework, say, then you'll have that skill when it comes time to take a quiz or an exam, and you'll avoid picking the nonsense answer that's there among the choices, and just get to the ones that actually could make some sense. All right, I'm reasonably confident that all of you can do unit conversion. Like I said, I'm just also confident that a majority of you perhaps will make some mistakes there along the way as the course goes on. So I want us to start off by focusing some attention on that and by trying to build good habits. Thanks.